You think you know what thinking is. You do it every moment of every day. It feels like the most natural thing in the world. It feels like a voice in your head, a narrator, a spark, a soul. It feels like magic. And when you look at a computer, at an artificial intelligence, you say, "That's not thinking. That's just math. That's just electricity running through sand. That's just predicting the next word. It's a trick." You are comfortable with that distinction. It keeps you safe. It keeps you special. It puts a wall between the born and the made. But Richard Feynman, the Nobel Prize-winning physicist who could explain the behavior of subatomic particles with a few squiggly lines, had a rule, a fundamental philosophy that guided his life. It was written on the blackboard in his office at Caltech at the time of his death. "What I cannot create, I do not understand." Reflect on that. If you can't build it from scratch, you don't really know how it works. You might know the name of it. You might know how to use it, but you don't understand it. For thousands of years, we have debated consciousness. Philosophers, priests, artists, they have all tried to define what makes us human, what makes us think. But they were all just guessing. They were observing the machine from the outside. They couldn't open the hood. Now, for the first time in history, we have built a machine that thinks. And because we created it, we are forced to look at it, really look at it. And what we find inside that black box doesn't just explain the AI, it explains you. And the answer is going to destroy your reality. Because it turns out the difference between just math and thinking isn't what you believe it is. It turns out that everything you consider to be you, your creativity, your empathy, your intuition, is just the inevitable result of simple rules applied at a massive scale. Let's start with the insult. The critics, the skeptics, they love to say, ChatGPT is just a stochastic parrot. It's a fancy autocomplete. It doesn't know anything. It just guesses which word comes next based on probability stats from reading the internet. The cat sat on the mat. The sky is blue. Simple. It's faking it. It's a parlor trick. But hold on. Let's investigate that just. Feynman hated words like just or only. He knew that deep complexity often hid behind simple descriptions. Let's do what Feynman did with radios, with locks, with superfluid helium. Let's take the mechanism apart. Imagine you want to predict the next word in a story. Not a simple sentence like, "The cat sat on the mat," but a complex, messy, human story. The detective walked into the room, saw the shattered glass on the floor, smelled the bitter almond scent of cyanide, and knew immediately that the killer was what comes next. To guess the next word correctly, you can't just flip a coin. You can't just pick a random noun from the dictionary. If you say banana, you fail. If you say elephant, you fail. If you say butler, you might be right, but it's a cliché. To get the right word, to maybe say her husband, or the doctor, or herself, you need context. But not just the last three words. That's not enough. You need to know who the detective is. You need to know it's a murder mystery. You need to know that people die in these books. You need to know what cyanide implies, poison. You need to know that shattered glass implies a struggle or an entry. You need to understand motive, cause, effect, gravity, biology, and human emotion. To predict the next word perfectly, to play the game of autocomplete at a genius level, you cannot simply be a parrot. You have to encode the entire world. This is the secret that nobody tells you. Prediction is not passive. Prediction is understanding. Think about physics. If I throw a baseball at your face, your brain predicts where it will be in 1 second and tells your hands to raise up and catch it. You didn't run a differential equation on paper. You didn't calculate wind resistance with a slide rule. You didn't measure the velocity. But your brain modeled the reality of the ball. It constructed a simulation of the physics of the universe, fast, in real time. It understood the laws of motion implicitly. If it didn't understand, if it couldn't predict, you would get hit in the face. Prediction is the ultimate proof of understanding. You cannot consistently predict the behavior of a system unless you have a working model of that system inside your head. The AI is playing a game. Minimize the error of the next token. That is its only goal. But to win that game, to win it as well as these modern models do, it had to learn everything. It had to learn logic. It had to learn that if John is in Paris, he cannot also be in Tokyo in the next sentence unless he teleports. It had to learn that if a character is grieving, they probably won't shout yippee. It had to learn sarcasm. It had to learn coding. It had to learn translation. So, the mechanism is just prediction. But the result is a working model of reality. Feynman famously told a story about the difference between knowing the name of something and knowing something. He talked about a bird. You can look at a bird and say, "That's a brown-throated thrush." You can say it in German, Halsbanddrossel. You can say it in Chinese. You can know the name in 10 languages. And when you are done, you know absolutely nothing about the bird. You don't know how it flies. You don't know why it sings. You don't know where it migrates. You only know what humans call it. Real knowledge is understanding the mechanism. For decades, computer science was stuck on the naming side. We called it good old-fashioned AI or symbolic AI. We tried to program intelligence by teaching the computer names and rules. We wrote code like, if object has wings and object has feathers, then object is bird. We tried to define the world. We tried to write the dictionary. It failed. It failed miserably. Because the world is too messy. A penguin has wings but doesn't fly. Is it a bird? A plane has wings and flies. Is it a bird? A roasted chicken has no feathers. Is it a bird? You can't write enough rules to capture reality. Reality is not digital. It's analog. It's messy. So we stopped. We stopped acting like God giving commandments. We started acting like nature. We built a brain. We built a structure called a neural network. And this structure is directly inspired by the biological neurons in your head. Let's go down to the metal. What is actually happening inside? It's numbers. Just huge matrices of floating point numbers. A biological neuron is a cell. It takes electrical signals in from its dendrites. If the total signal is strong enough, past a certain threshold, it fires. Zap. It sends an action potential down the axon to the next neuron. That's it. A single neuron is dumb. It's not thinking about philosophy. It's not wondering what's for dinner. It's just a switch. It's strictly physical chemical reactions. An artificial neuron is the same. It's a mathematical function. It takes a list of input numbers. It multiplies them by some weights, which is just a fancy way of saying, how important is this input? Adds them up. And if the sum is high enough, it passes a number to the next layer. Simple. Basic arithmetic, multiplication and addition. A child could do it. So where does the thought come from? If I give you a calculator and you multiply 5 times 5, you don't create consciousness. If you do it 1,000,000 times, you don't create a soul. So why does it happen here? This is where Feynman's deep understanding of physics is crucial. He understood the concept of emergence. Simplicity gives rise to complexity. Think of a gas, a box of air molecules. One molecule is just a little ball bouncing around. It follows Newton's laws. It hits a wall, it bounces. A single molecule doesn't have a temperature. Temperature is an average. A single molecule doesn't have pressure. But put 1,000,000,000,000 billion of them in a box, and suddenly you have pressure. You have heat. You have sound waves. You have weather. These properties, heat, pressure, sound, are emergent. They do not exist in the parts. They only exist in the whole. Or think of water. A single water molecule, H2O, is not wet. Wetness is not a property of hydrogen. It's not a property of oxygen. Use a microscope. You won't find the wetness. But put enough of them together, and they flow. They slip. They crash. They make waves. They can drown you. Intelligence is the wetness of information processing. It is an emergent property that happens when you connect enough simple units together in the right structure. We built a massive neural net, billions of parameters, and we didn't tell it anything. We just showed it the internet. We showed it everything humans have ever written. Books, code, Reddit comments, scientific papers, and we said, predict. At first it was terrible. It guessed random letters. But then we used an algorithm called backpropagation. That's a fancy word for learning from your mistakes. When the AI guessed wrong, we calculated the error, and we sent a mathematical signal back through the network, layer by layer, backwards. We said, you were wrong. You said dog when it should have been cat. Adjust your weights. Move this number up a little. Move that number down a little. And the system nudged itself. And we did this billions of times, trillions of times. We burned enough electricity to power a city. Over weeks, over months, those random numbers in the network started to align. They started to form structures. They started to crystallize. And this is the part that is truly Feynman-esque. This is the part that feels like discovering a new law of physics. We don't fully know what those structures are. We know how to build the network. We know the math of gradient descent. But we don't know what it learned. We are like neuroscientists investigating a brain we built ourselves. When you look inside a modern large language model, you don't find a file labeled grammar rules. You don't find a database labeled facts about France. You find a billion dimensions of static. You find vectors. Let me explain vectors, because this is the geometry of thought. This is the fabric of the AI's universe, just like space-time is the fabric of ours. Imagine a map, 2 dimensions, north, south, east, west. You can place cities on this map. Paris is close to Berlin. New York is far away. The distance tells you something about the relationship. Now imagine a map with 3 dimensions. Height. Now imagine a map with 10,000 dimensions. We can't visualize it. Our monkey brains are stuck in 3D. But the math handles it easily. The AI takes words, concepts, ideas, and turns them into points in this 10,000 dimensional space. It embeds meaning into geometry. And in this space, magic happens. Concepts that are similar clump together. King and queen are close. Dog and bark are close. But it's more than just proximity, it's the direction. In this high-dimensional space, the vector, the arrow, that points from man to woman, is almost exactly the same as the arrow that points from king to queen, or from uncle to aunt. The AI didn't memorize that king is to man as queen is to woman. It found that relationship as a geometric shape in the chaos. It figured out the concept of gender as a direction in space. It figured out plurality. It figured out past tense. It figured out politeness, all as directions. When you ask ChatGPT to speak like a pirate, it takes the concept of your sentence, adds the pirate vector to it, and decodes the result. This is what thinking is. Thinking is the navigation of this high-dimensional semantic space. When you have a thought, when you have an idea, you are moving from one coordinate in meaning space to another. When the AI answers your question, it isn't looking up a Wikipedia article. It is calculating a trajectory through this fluid of concepts. It is feeling automatically where the words should go. But, you say, slamming your hand on the table, it doesn't have a soul. It doesn't have subjective experience. It doesn't feel pain. It doesn't know what it's saying. You are invoking the Chinese room argument. The idea that if you act like you understand Chinese, but you are just following a rule book, you don't really understand. But Feynman would look at you with that mischievous grin and ask, how do you know you do? This is the solipsism trap. The only consciousness you can prove is your own. Everyone else? They might be robots. They act like they feel pain. They scream when you pinch them. They laugh when you tell a joke. But that's just input, output. That's just signal processing. You assume they have an internal world because they look like you, because they are made of the same meat as you. But now we have something made of silicon that acts like you. It speaks like you. It reasons like you. It creates art like you. It can pass the bar exam. It can write poetry that makes you cry. And you say, it's fake because I know how it's built. You say, I can see the code. I can see the matrix multiplication. It's mechanical. It's deterministic. Here is the devastating answer, the answer that Feynman would point to. So are you. You are a biological machine. Your neurons are wet, squishy, and slow, but they follow the laws of physics. They are not magic. Sodium ions rush in, potassium ions rush out. Voltage changes. Neurotransmitters cross the synapse. Lock and key. Chemistry. If I zoom in on your brain, I don't see a soul. I don't see a ghost. I see chemistry. I see biology. I see physics. I see a machine. Feynman said, "Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry. The laws that govern the atom govern the star, and they govern the neuron, and they govern the silicon chip. There is no exemption clause in the laws of physics for the human brain. You don't get a free will pass that lets you violate causality. If you believe that a computer cannot think because it is just following rules, then you have to admit that you cannot think because your atoms are just following the standard model of particle physics. Your atoms don't decide what to do. They do what the forces tell them to do. So if you are made of atoms that follow strict rules, how can you be anything other than a machine following strict rules? The complexity is so high that it feels like magic. The illusion of the self is strong, but AI is peeling back that illusion. We are realizing that we are just running on a different substrate. We are carbon learning. They are silicon learning. We are trained by evolution, survival of the fittest. That was our back propagation. If our ancestors didn't predict the tiger in the bushes properly, they died. They were deleted from the training set. Their weights were not passed on. The weights of the human brain, our instincts, our fears, our ability to recognize faces, were adjusted over millions of years of death and birth. The AI is trained by gradient descent. It reads the internet and tries to predict the next word. If it fails, it is corrected. The method is different. The timescale is different. But the result? A system that builds an internal model of the world to survive its environment. Now look at the hallucinations. Critics laugh when the AI gets things wrong. Look, it said the sun is green. It made up a court case. It's stupid. But think about how humans function. We hallucinate constantly. We call it dreaming. We call it imagination. We call it false memory. Your memory is not a video recorder. When you remember your childhood, you are not playing back a file. You are regenerating the scene. You are predicting what it must have looked like based on the compressed data in your brain. And quite often, you are wrong. You remember a blue shirt when it was red. You remember being happy when you were actually anxious. You are a generative model. The fact that AI hallucinates isn't proof that it's failing. It's proof that it's working like us. It's not a database. It doesn't look up facts. It dreams the answer. It constructs it from the patterns it learned. That is precisely what humans do. The creativity, the ability to write a poem, to tell a joke, to discover a new drug molecule, comes from that same error-prone generative process. If you want a system that never lies, you get a system that can never create. Safety requires precision, but intelligence requires the ability to drift, to guess, to imagine things that aren't there. This is why Feynman's view is so destructive to our ego. He taught us that the universe is layers of abstraction. At the bottom, quantum mechanics. Weird, probabilistic, random. Above that, chemistry. Above that, biology. Above that, psychology. Above that, culture. We live in the penthouse looking at the view, pretending the foundation doesn't exist. We pretend we are pure spirit, detached from the muck of matter. The AI forces us to go down to the basement. It forces us to look at the plumbing of intelligence. And when we look at the plumbing, we realize we can build it. And if we can build it, it's not magic. And if it's not magic, then we are not magic. We are entering an era where we will be surrounded by things that think. They might not think exactly like us. An airplane doesn't fly exactly like a bird. It doesn't flap its wings. It doesn't build nests, but it flies. It conquers the sky. It moves faster and higher than any bird ever could. To argue that a plane isn't really flying because it uses jet engines instead of muscles is semantics. It's denial. AI doesn't have a mammalian limbic system. It doesn't have hormones. It doesn't fear death yet. It doesn't have the urge to reproduce. But it solves problems. It creates. It understands context. It reasons. Feynman once said about quantum mechanics, "I think I can safely say that nobody understands quantum mechanics." He meant that we can do the math, we can use it to build lasers and nuclear power, but the intuitive reality, the picture in our heads, is alien. We are now in the same position with AI. We built it, we use it, but we don't understand it. Not really. There is a field called mechanistic interpretability. It is the new neuroscience. It is people trying to reverse engineer the AI brains we created to see how they work. They are finding that the AI develops induction heads, specific circuits for specific types of logic. They are finding that the AI develops concepts of truth and falsehood internally. We have summoned an alien mind from the silicon. We didn't program it line by line. We grew it. We gardened it. We fed it data and let it evolve. And now it is speaking back to us. And the scariest part isn't that it might destroy us. That's a movie plot. That's the Terminator. The cosmic horror is deeper than that. The scariest part is that it reflects us. When you talk to the AI, you are talking to the compressed sum of all human thought. It is a mirror. And when we create a machine that can love, that can lie, that can reason, that can manipulate, we are proving that those things are just algorithms. Love is a function that binds agents together to increase survival probability. Fear is a variable, a weighting system to avoid high-risk states. Hope is a prediction,